Hello YouTube, welcome to this video, and today I'm going to be showing you how to find the maximum height of a projectile fired from the ground. So in this question we have a projectile that is fired from the ground with an initial velocity of 25 meters a second with an angle of 45 degrees from the horizontal. So if we were to graph or make a picture of this such that the y-axis is the height and the x-axis is the displacement. I'll call that h and d for now. Essentially, we're starting off the ground here, where x is equal to, or rather y is equal to 0, and we basically have a velocity vector, the initial velocity vector, with a magnitude of 25 meters a second, 25 meters a second, and then the angle, the direction is 45 degrees. So what's our goal? Well, we're trying to find this point, and we're trying to find the y value of that. So the value on the y-axis. So there, we're trying to find out that number. So the way we can do this is, instead of doing height in terms of the displacement, we will do height in terms of the time, delta t, or t. So essentially we can form a function called h of t. And with all projectile motion problems, when you're putting height in terms of time, it's always equal to this generic format, and that is equal to the gravitation of Earth, g, or I should put minus g over 2 times time squared, plus the initial velocity component in the y, the initial velocity y component times the time, plus the initial height naught. Alright, so if we were to simplify this right off the bat, we know g is 9.8, so it's downward direction, or we're considering the positive y direction to be upward, so therefore we put the minus sign there. And so there we do, h of t is equal to, that would be minus 9.8 over 2, so that would be minus 4.9 t squared plus VIYT plus, well, in this case, h naught is 0. This is 0 meters. Therefore, you know what? We can just, we don't need to write that. I'll just take that out. Okay. So we're close to defining a function here, but we need one more thing, which is VIY. And excuse me, if I just write this here, we can now figure this guy out. So we got to basically, we have this, I'll draw it out separately here. We have this 25 meters a second, 45 degrees. It's pretty simple. Finding out the y component. Whenever you're finding out the y component in projectile motions, just do 25 sine theta, where the angle is, in this case, 45 degrees. That's it. And now, say you're finding the x component, you'd replace the sine with a cosine. But anyway, plus 25 sine 45 degrees times t, and I'll put that in brackets. There we go. Now, to find the maximum height, we gotta first know where it'll land on the x-axis. So we're gonna find t max, and always in parabolas, the x variable of the maximum height, or the maximum vertex, I should say, that's always going to be minus b over 2a, and that is derived from differential calculus. So if we use this, we can do minus 25 sine 45 over 2 times minus 4.9 equals, and plugging this into the calculator, it gives me approximately, so I'll put that little dot there, 1.8 seconds. Alright. Now, what I can do, I can plug in Tmax into h of t, so I'll do h at Tmax is going to be equal to minus 4.9 times 1.8 squared plus 25 sine 45. And for simplicity, sine 45, you can plug that in as root 2 over 2. Sine 45 degrees multiplied by 1.8. Alrighty. That is approximately equal to 15.9 meters. And yes, I did plug in the exact value of this term into here rather than 1.8 while we're doing it on the calculator. So yeah, it's approximately equal to 15.9 meters. So that means that if you have a projectile fired at 25 meters a second at 45 degrees above the horizontal, with the gravity of Earth being 9.8 meters a second squared downwards, you're going to have a maximum height of 15.9 meters for the projectile. Thank you for watching this video. I hope you were able to get a lot out of it. And please consider to like and subscribe. Thank you very much.